In this lesson, we are going to learn how to write an equation in the form of y equals mx plus b if we're given a table of values to work with. So when we have an equation in the form of y equals mx plus b, a couple of variables that we need to know are the m actually stands for the slope of the relation, and the b part actually stands for the y-intercept. So when you're writing an equation, you will see the letter or the variable y and the variable x, but the m and the b will be replaced by numerical values. So in order to find the slope, we can use the slope formula of y2 minus y1 over x2 minus x1. So in order to find the slope, we need 2 points that will be on the line, and from those 2 points we can then calculate the slope. So in this example, we first want to find the slope of our line, then we want to find the y-intercept, and once we found those two, then we can actually write the equation in y equals mx plus b form. So to find the slope, I'm just going to choose any 2 points that are given to me in the table of values. So we have 4 points, we can choose any 2 of them. So I'm going to choose the first one of 0, 100, and the second one of 25, 350. So with these 2 points, we just want to label them as x1 and y1, and x2 and y2. So my first point will be x1, y1. My second point will be x2, y2. So it doesn't really matter which one you call the ones, which ones you call the twos. I could call the 25, 350 x1 and y1 as long as I have the ones from one point and the twos from the second point. So now I'm going to substitute my x and y values into the slope formula. So I'm going to start with y2, and slope is represented by m. So our y2 is 350, and I'm going to subtract the y1 value of 100. And in the denominator, I'm going to start with the x2 value of 25 and subtract the x1 value of 0. So when I calculate this, 350 minus 100 is 250. In the denominator, 25 minus 0 is still 25. And when I calculate this, 250 divided by 25 gives a value of 10. So the slope of this function is 10. So now I want to determine the y-intercept. So the y-intercept comes from the point where the x value is 0, and then we're looking for that y value, and that will be our y-intercept. So in this example, looking at that first point, 0, 100, the 100 is the y-intercept because the x part is 0. So 0, 100, so our y-intercept is represented by b. So the y-intercept is 100. Writing the equation, we want to write this in the form of y equals mx plus b. So y equals the slope times x plus the y-intercept. So I know the slope, which is m. I know the y-intercept, which is b. I'm just going to take those 2 numbers and put them into the right spot. So we want a y in our equation. Our m is going to be replaced by the 10. We want to see the x in the equation, and the b is going to be replaced by the y-intercept, which is 100. So positive 100, so that's why we put plus 100. So our equation for this example is y equals 10x plus 100. In this next example, again, same 3 things that I'm trying to find. So we're going to start with the slope. So again, choose 2 points. Again, it doesn't matter which one it is. I'm going to choose the first point of 0, 12, and the second point of 4,000 and negative 13.6. Again, I'm going to label my brackets with x1, y1, and x2, y2. Now to figure out the slope, we use the slope formula. So y2 minus y1, so our y2 is negative 13.6. I'm going to subtract y1, which is 12. In the denominator, we start with x2 of 4,000, and I'm going to subtract x1, which is 0. So I'm going to calculate this. So negative 13.6 minus 12 is negative 25.6. 4,000 minus 0 is still just 4,000. And now I'm going to divide the 2. And when I do that, I get a value of negative 0.0064. Now looking at the y-intercept. Again, the y-intercept comes from the point where x is 0. So that's the first point in the table. So we have 0, 12. So our y-intercept is the y value when x equals 0. So our y-intercept is represented by b. So b equals 12. So now to write the equation, again, we're working with y equals mx plus b. We just need to replace the m and the b with numerical values. So we're going to have y equals, our slope is negative 0.0064. We want to see that x multiplied by the slope. And then we need to add on our y-intercept. So it's positive 12. So we have a plus 12 at the end. Same thing in this next example. So we're going to start with the slope. I'm going to use the first 2 points. So 0, 0, and 4, 6. I'm going to label them x1, y1, and x2, y2. So now I'm going to substitute these into the slope formula. So y2 is 6. I'm going to subtract y1, which is 0. In the denominator, our x2 is 4. And subtract the x1 again, which is 0. So the calculations for this one are pretty basic because we're subtracting 0 each time. So we'll get 6 over 4. And 6 divided by 4 is 1.5. For the y-intercept, again, I need to choose the point where x is 0. So that is going to be the first point of 0, 0. So this time, our y-intercept is actually 0. So now to write the equation, again, we start with y equals mx plus b. We want to see the y in the equation. Our m is replaced by 1.5. This gets multiplied by x. And then we have our y-intercept, or the b value, of 0. So you don't need to put the plus 0 at the end of the equation. So y equals 1.5x is our final equation. One last example of this. So again, find our slope. So I'm going to use the points 1, 3, and 2, 6. Label them x1, y1, x2, y2. Substitute this into the slope formula. So our y2 is 6. We're subtracting our y1, which is 3. In the denominator, our x2 is 2. Subtract the x1, which is 1. So when we calculate this, 6 minus 3 is 3. 2 minus 1 is 1. And 3 divided by 1 is just 3. For the y-intercept, again, we need the point where our x value is 0. We don't have a point like that in our table of values, so we have to work our way backwards in order to figure out what that point is going to be. So in our x values, if we start at 3, we decrease by 1 to get to 2, decrease by 1 to get to 1. If we decrease by 1 one more time, we will get to 0. Now we need to figure out the y value. So 9, decrease it by 3 to get to 6, decrease by 3 to get to 3. If we decrease by 3 one more time, we will also get to 0. So we have the point 0, 0, which tells us that our y-intercept is 0 in this example. So our b equals 0. So writing the equation of this line, we're going to have y equals mx plus b. We need our y variable. Our slope is 3. That gets multiplied by the x. And then again in this one, our y-intercept is 0. We do not have to put the plus 0 at the end of the equation. We can just leave it as y equals 3x. In this example, Dominic drives a taxi. His mileage records show that he uses an average of 10 liters for each 100 kilometers he drives in the city. At the start of his shift one morning, he fills his gas tank with 75 liters of gas. Below is a table of values showing the amount of fuel remaining. So we're using this table of values in order to answer these questions. So the first question says, is this a direct or partial variation? So remember from the last lesson, a direct variation will go through the point of 0, 0. A partial variation does not go through the point 0, 0. So in this table of values, we see that we go through the point 0, 75. So it does not go through the point 0, 0. So this is partial. Is this an increasing or decreasing relation? So if we start with our smallest x value of 0 and work our way down the table, when we look at our y values, we have 75, we go down to 65, down to 55, down to 45. So because it's going down each time, this is a decreasing relation. The next question says, what is the y-intercept and what does it represent? So the y-intercept, remember, is the point where x is 0. So that point is 0, 75. So the y-intercept is 75. So b equals 75. What does this represent? So 75 is the fuel remaining in the gas tank in liters. And the 0 part is the distance that's driven. So the 75 represents how much fuel is in the gas tank if you haven't driven any kilometers. So we've got 75 liters of gas. After driving 0 kilometers. So basically it means that there's a full tank of gas that has 75 liters in it. Next we want to calculate the slope and determine what the slope represents. So our slope, remember, we need to choose 2 points from our table of values. So I'm going to choose 0, 75, and the second point of 165. I'm going to label this with x1, y1, and x2, y2. So using the slope formula, we're going to start with y2, which is 65, and we're going to subtract y1, which is 75. In the denominator, we'll start with our x2 of 100 and subtract our x1 of 0. So when we calculate this, 65 minus 75 is negative 10. 100 minus 0 is 100. When we divide this, we'll get negative 0.1. So what the slope represents, when we calculated this out, our y values were actually the liters of gas remaining in the tank, And our x values were the kilometers that were driven. So when we calculate our negative 0.1, this is actually liters per kilometer. So the slope tells us that for every 1 kilometer that's driven, the fuel decreases by 0.01. By 0.1 liters after driving 1 kilometer. So for every kilometer that is driven, the gas decreases by 0.1 liters. So now we want to write an equation that describes the amount of fuel remaining compared to the number of kilometers driven, which is what the whole example is all about. So again, we can use our y equals mx plus b. And again, we know we want to see a y there. We want to replace the m with the slope, which is the previous question. So that's negative 0.1 times x, plus our b value, which is our y-intercept of 75. So plus 75 at the end. So the last question says, using the equation that we just created, determine how much fuel will be remaining when Dominic has driven 175 kilometers. So we have a choice of where to put this 175 kilometers. We can put it in the y position, or we can put it in the x position. If we look at our table of values, the x column is the kilometers, the y column is the fuel. So we have the kilometers that have been driven. So because we know that number, we're going to put that into the kilometer piece, which is in the x position. So we're looking for y. Instead of an x, we're going to put in the 175 kilometers. And now we're just going to calculate this. So negative 0.1 times 175 is negative 17.5. And then we'll have the plus 75 at the end. When we add these two together, we will get 57.5. And what we're looking for is how much fuel. So this will be liters. So there will be 57.5 liters remaining after Dominic has driven 175 kilometers. In this last example, Marin is taking an apprenticeship to become a cook. In Alberta, an apprenticeship program for cooks requires 1,560 hours of on-the-job training. Marin estimates that she will complete 25 hours of training each week. The table shows the number of hours she has completed so far. So after 2 weeks, she completed 50 hours of training. After 3 weeks, she completed 75 hours, and so on and so on. So the first question we want to answer is this relation linear? So for a linear relation, our x values have to increase or decrease by the same amount, which they do. They increase by 1 each time. Our y values also have to increase or decrease by the same amount, which they do. They go up by 25. So is this relation linear? Yes, it is. Is this relation direct or partial? So for direct or partial, we have to determine whether it goes through the origin of 0, 0. So we have to create a couple more values. So if it was week 1, we would decrease the hours of training by 25. And in week 0, decrease the hours of training by 25 again. So in week 0, she would have 0 hours of training, which makes sense. So this will be a direct variation because it goes through the point 0, 0. So is this relation increasing or decreasing? So as our x values increase, our y values are also increasing from 50 to 75 to 100. So therefore, this is an increasing relation. Next part says, what is the y-intercept? So our y-intercept is always the point where x equals 0. So in this case, it's 0, 0. So our y-intercept, represented by b, is 0. What does this point represent? This represents that in week 0 of the apprenticeship, there have been 0 hours of training completed. Next part says, what is the slope? So we need to calculate the slope. And I'm going to choose to use the first 2 points that are in the table. So in the original table, I'm going to choose 250 and 375. I'm going to label this x1, y1, and x2, y2. So using the slope formula, we start with our y2 of 75. We subtract our y1 of 50. In the denominator, we start with our x2 of 3, subtract the x1, which is 2. When I calculate this, 75 minus 50 is 25. 3 minus 2 is 1. So we get 25. And if we include the units, this will be hours of training compared to the number of weeks in the apprenticeship program. So what does this represent? This tells us that for every week of training, for every week of the apprenticeship, Marin will have 25 hours of training. The next question asks, what is the equation of a line? So this is our y equals mx plus b. We've already determined the y-intercept, which is 0. And we've also determined the slope, which is 25. So we need to substitute these in to create our equation. So we will have y equals, m is our slope of 25. We'll multiply this by x and then add on the y-intercept, which is 0, so we don't need to put the plus 0 at the end. So y equals 25x. The last question, we want to use the equation that we just created to determine how many weeks it will take Marin to complete 1,225 hours of training. So we have to figure out, is the number of training hours the x value or the y value? So if we look at our table of values, the training hours is actually in the y column. So our 1225 that we've got down here is going to be a y value. So in our equation, we've got y equals 25x. We determined that the 1225 should go in the y position. So we're trying to figure out what x is, and that will tell us how many weeks it will take Marin to complete this training. So we don't have anything to add or subtract, so all we need to do is divide by 25. So our x value will be 49 weeks. So after 49 weeks, Marin will have completed 1,225 hours of training.